Joe Powell, Chief Scientist, Chemical Engineering for Shell, presenting Thriving Amidst the Energy Transition. Don't take anything I say as investment advice. Shell's strategy and plans for targeting net zero emissions is work in progress. By 2050, the world's population and energy demand will both increase by 1/3. Annual global CO2 emissions would increase to 43 gigatons due to growth in non-OECD activities. To mitigate climate risk, annual emissions should be reduced to 18.4 gigatons by 2050, while still satisfying energy demand. Shell targets net zero emissions from its own activities by 2050, and a pathway for its customers to do the likewise via a combination of clean energy products and offsets. The world started with bioresources as a primary energy in the 1800s, and then transitioned to coal, oil, and gas due to increased efficiency, but now seeks to move back to the less dense distributed energy resources. Providing for 24/7 clean energy is the energy challenge of our time. A roadmap to net zero emissions requires integrations of biofuels, renewable energy, as well as carbon capture storage and utilization and nature-based solutions as CO2 sinks. So you see the bottom right portion of the chart growing substantially going into the future. By the end of the century, a majority of energy is produced from renewable resources, including wind and solar. The physical scale of mass of molecules which must be manipulated to supply global energy needs is absolutely enormous. It dwarfs production of chemicals for consumer products. Given the massive size and cost to society, multiple decades are required to invest and make a material change in energy infrastructure. On the right-hand side, you see the typical time required for infrastructure turnover to date. This is why we speak of an energy transition, which will have to occur at an unprecedented pace in order to address climate goals. With the fracking revolution, the US Gulf Coast has an advantaged opportunity to supply clean energy via natural gas to meet world needs. For gas that is not used locally and distributed by pipelines, LNG has been the most economic option to date for gas monetization for transport to distant markets. For future clean energy, natural gas reforming to make hydrogen with storage of carbon provides a compelling option for growth, again advantaged for the US Gulf Coast region. Hydrogen utilization is projected by the US DOE to grow 5 to 10-fold over current levels in order to meet the demands for a clean energy future economy. The future will see much more carbon capture and storage, including the option for negative emissions technologies where CO2 is originally derived from either direct air capture or from use of biomass. Use of depleted hydrocarbon reservoirs prevalent in the US Gulf Coast, including oil industry expertise provided, is an advantage for the region. To enable customers to reduce their carbon footprints, much of future final energy distribution will occur as clean electricity, shown here in deep blue, and hydrogen in pink. The lower right shows that much of the hydrogen use will occur in road transport, where heavy-duty trucking is advantaged relative to electrification. Electrification must occur at a prolific rate. Hydrogen, shown in light blue here, integrates and supports electrification in deep blue, and continued use of hydrocarbon, solar, or biofuels, shown in red, which also often requires hydrogen inputs. And this occurs as one considers energy efficiency, density, and infrastructure requirements for what are the best end-use options. A combination of all will be needed to optimally decarbonize all sectors. Here's a proposed roadmap for hydrogen use in the U.S. Gulf Coast. Hydrogen can be produced from abundant wind and solar resources in Central and West Texas, or via natural gas with CCS at lower costs than could be obtained in California or the Northeast. 2,700 kilometers of hydrogen pipeline between Texas and Louisiana can provide for decarbonization of Gulf Coast industries and include the option for salt dome storage of renewable or clean energy. Regional road transport can convert to hydrogen fuel cell vehicles to meet corporate commitments for carbon footprint reduction. So certainly hydrogen fuel cells are particularly advantaged in commercial fleet applications. Integration and stacking of sector use is needed to obtain the scale needed for low-cost hydrogen production and distribution. The details of this are described in the US DOE's H2 at Scale website and associated literature. Export of clean hydrogen to Japan or Europe is also a market opportunity for the US Gulf Coast, given the globally advantaged natural gas and CCS costs. Other hydrogen hubs are also plausible globally. Here is a look at Shell's current footprint, but certainly port hubs in the US, Europe, and Japan are also a significant part of the future play that can be realized in the hydrogen economy. As we said, commercial fleets are advantaged via the uptime provided by rapid hydrogen refueling versus the alternative option of battery recharging for electrified fleets. This is why fuel cell lift trucks and forklifts have taken over the market, as in Home Depot, Amazon, and Walmart warehouses, where no subsidy is needed for this to happen. This map also shows that current US hydrogen production is centered along the US Gulf Coast region in support of refining, petrochemicals, and related industries. The US hydrogen roadmap released in March shows the expected expansion in future demand, along with sector integration opportunities, which again are particularly advantaged at port locations such as the Port of Houston or Long Beach. The report includes the fact that hydrogen fuel cell vehicles could achieve total cost of ownership parity with current internal combustion engine models by 2030, given the fewer number of components required in the vehicle drivetrains, 1,500 for hydrogen fuel cell vehicles versus 3,000 for current internal combustion engine vehicles. In summary, the energy transition provides tremendous opportunities to supply the future clean energy solutions desired by our stakeholders. And a lot of this activity can be occurring on the US Gulf Coast area, given its richness in fossil hydrocarbon production, ability to use that depleted reservoir access base for carbon capture and storage, and also the access to natural gas, plus abundant solar and wind resources. So these are very exciting times for chemical engineers. Thank you, and I'll be happy to answer any questions.